Hi, I am Rajab Legnain, a software developer at Venable Instruments. In this video, I will show you how to use the Venable RLC measurement accessory along with the Venable FRA to measure and characterize the impedance accurately and easily. In this tutorial, we will use the Venable FRA 6340 and Venable RLC Measurement Package to measure the impedance of the 2.2 microfarad electrolytic capacitor. The RLC measurement package includes the RLC test fixture, the axial leads adapter, and the Venable RLC software tool. The RLC test fixture is designed to be connected directly to an analyzer to minimize the parasitic impedance of long cables, and it uses Kelvin connections that provide accurate measurement by eliminating the probe resistance. Connect the RLC test fixture to the Venable FRA as shown. Before taking measurement, we must perform the calibration process on the system. In the calibration process, the Venable Stability software estimates the values of parasitic components that are presented in the RLC test fixture. Then the software will use these estimated values to remove the effect of parasitic components from the actual measurement of the RLC circuit and to improve the accuracy. The calibration process consists of two steps: open circuit sweep and closed circuit sweep. The open circuit sweep measurement is used to estimate the parallel parasitic impedance, while the short circuit sweep measurement is used to estimate the series parasitic impedance. Turn on the instrument and wait for it to complete the boot up. Once the instrument is ready, the LED light of the channel 1 and 2 will turn to green. Open the Venable Stability software and then open the Analyzer program menu to connect to the analyzer with the USB. Once the analyzer is connected, the Analyzer control panel and the RLC control panel will be enabled so that you can configure the setting. First, we go to the Analyzer control panel and configure the sweep and generator settings. We set the start frequency to 10 Hz and the stop frequency to 30 MHz. We set the AC voltage output to 8 volt. Larger AC voltage output values improve the measurement accuracy. And we set the DC voltage output to 0. Leave the default settings, sine wave for the waveform and 50 ohm as the output impedance. Next, we configure the integration settings. We set the integration time to the medium, which is 2.5 seconds for 6340 for the best measurement speed, and we set the delay to 0. Longer integration time increases the sweep time, but the measurements are more accurate. Leave the channel input impedance at 1 mega ohm. Next, we configure the RLC settings. We set the reference resistor to 100 ohm. This is the value of the current measurement resistor built into the RLC test fixture. The channel select function allows the RLC test fixture to be used on alternative channel combination for Venable FRA that has 3 or 4 channels. The FRA 6340 features 2 channels, so we select the 1 and 2. We select smaller than 10 volt for the peak voltage. Once we have completed the RLC configuration, click the calibration button. The software will ask you to open the terminals of the axial lead adapter on the RLC test fixture to perform the open circuit sweep measurement. If the displayed graph is not an impedance graph, the software will create a blank impedance graph. The software will take 4 measurements at the start frequency before beginning the sweep to the stop frequency. Once the sweep is started, the software will create a dataset and start plotting the measurement data in real time. We can see that the graph doesn't view the impedance curve and its upper frequency limit is below the stop frequency. Click the graph setting button to change the scale limit. Click the auto button for the impedance axis to automatically scale the limits and view the impedance data. And then Set the maximum frequency to 35 MHz to display the stop frequency. When the open sweep is completed, a message appears asking whether you want to repeat the open circuit sweep or continue the calibration process. We click the Continue button. The software will ask you to close the circuit. Close the terminal on the RLC test fixture using a shorting bar and click OK. You can cover both edges of the shorting bar with copper tape to improve the conductivity and thus improve the closed circuit results. When the closed circuit sweep is done, a message will appear asking you if you want to redo the closed circuit sweep. Click Keep It button to accept the measurement result and finish the calibration button. The calibration can be saved to another file for use in the future, so there is no need to recalibrate the system when opening a new file to measure a different component. Now we have the system calibrated. We can start measuring the circuit impedance. First, connect the capacitor to the terminals on the RLC test fixture and then click the test component button. A message will appear asking to connect the component that you want to measure. We have already connected the capacitor, so we can click OK. The software will start measuring the capacitor impedance. When the sweep is started, a new dataset will be created and the graph begins plotting the data in real time. To reduce the clutter in the graph, we uncheck the open circuit and closed circuit dataset to hide them. Once the measurement is done, the software will create a dataset for the actual impedance without parasitics. The software uses math on the calibration data to remove the parasitics. The RLC software also provides a function to create a theoretical model for the circuit that was measured. It has several mathematical models, which is a combination of a resistor, a capacitor, and an inductors, arranged in parallel or series. To model the capacitor that was measured, click on the Model tab and select the component and the dataset. Each time you select a different component or dataset, the values of R, L, and C will be updated. Then click the Create Plot button. The software will create a dataset and plot the theoretical model. To generate a report in Microsoft Excel XML format, click the Report tab. Select the information that you want to be included in the report and click the Create Excel XML Report button. A file save window will appear. Select the folder in which to save the file, type the file name and click the Save button. To view the report, run the Excel software, click Open File, locate and select the file, then click the Open button. The report includes the data in tabular format and information about the model. Thanks for watching this tutorial about the RLC measurement function. Visit www.venableinstrument.com/blog for more blog tutorials.